Hi, this is Navin. Today my topic is Personal Expensive Tracker app. Introduction. The Personal Expensive Tracker is a smartphone that is a mobile application developed to help its user manage their expensive as they spend on daily and long-term financial activities developed using Android Studio. The application uses Firebase service to ensure authentication and the security of its user data. It allows user to add, waive, edit, delete and filter expensive as for category, date and location. Additionally, the application provides graphical instance charts and also allows the user to customize the theme. The project focus on delivering a good, expensive, user-friendly interface with the best practices in modular architecture and software development. Use case diagram. We have 8 use case diagram. The application is centralized on a single primary actor which the user can interact with all the core function within the application. These function includes registering or logging into application, adding expensive, waiving expensive added, waiving today's spending, applying filters, analyzing report in insets, switch the interface theme, and managing your account settings such as password. In the case, clarify the overview of the application communication. The figure use case diagram is logging and usually in both application design and collaborate development. Use case documentation. Use case 1, register and log in, and use case 2, add expensive, and use case 3, waive expensive, use case 4, waive insert, use case 5, change theme, use case 7, dashboard, and the last use case 8, today's spending. Class UML diagram. This class diagram shows the core structure of the application. The main relationship is shown in the user class and the expensive class linked via the primary key user ID, which ensure that each expensive is linked to the correct user and another user cannot access the data for a different user. This expensive class take expensive details such as a title, amount, category, date and location. Supporting classes like insets and setting are included to the process reports, data visualization and user preference responsibility. This modular architecture separates the responsibility, ensuring the application is easier to manage, scales and test. The engineering promotes a logical and maintainable code base by making sure that each class acts to their specific purpose within the overall system. It provides a clean object oriented based for further technology enhancement such as a budgeting. Design pattern used. Singleton pattern. In the proportional expensive tracker application, singleton pattern is used by the way resources are being shared, such as Firebase Youth and Firebase Firestore are accessed through a get instance. There are only to have one shared instance throughout the application lifecycle. For instance, Firebase Auth get instance is called in main activity to handle user authentication. This prevents memory leaks, maintains authentication and supports global access. Observer pattern. The observer pattern is highly used in live data and wave model. The UI observation the live data from expensive wave model, and when the data changes in the Firestore, the UI on real time if a change get it add a snapshot listener to get updates patterns have improved responsiveness, also ensuring a reactive approach to get user experience. Forget pattern. The forget pattern in main activity abstracts negation complexity managing subsystem like add expensive, least expensive, insert setting and logout enabling unifield controlling and enhancing overall expenses. SDK future user. Firebase SDK provides authentication for a secure user sign into the user using email password for third party provides. It streamlines implementation control seasons and integrates seamlessly with real-time database access and user specific data control. Sequence diagram. Register sequence. The sequence showcase a sequence diagram for the personal expensive tracker app showing how the Android app complements interact during new user registration. When a user hits the submit button, the user interface capture all the input and send it to the controller and the validation take place. The controller send data to the repository with it is validity in the repository. The data is stored in the file store. Add expensive sequence UI controller repository file store. Show user registration flow in personal expensive tracker. Wave expensive list sequence. This sequence shows how pet features and displays the current and previous expensive after the user open this list wave screen. The activities related to the login user extensive wave speech and queries Firestore for expensive added. The written data is then deposited to recycler wave which render the least expensive on screen. Filter expensive sequence. Filter UI activity Firestore display shows how pet filters expensive by date or category. Changing password sequence. Change password activity fire the display show how password alternation take place. User interface diagram. Register. The new user begins with the actor with the personal expensive tracker application through the Firebase authentication which enforce the user to set up an account to get started. Dashboard main activity contains these cards, summary cards, displaying current day tools, expensive the tool location spent on its node to help the user organize expensive and an automatically generated usual card for all the expensives. Add expensive. The add expensive component of all the user input fields required to add an expensive field includes the title amount, category, selection and date. The activity captures the user data and send it to expensive Java to handle the process of saving the data in this database. On the left is dark mode and on the right is light mode. Least expensive history. The list of expensive history features and display all the user added expensive depending on the logged in user in the application. Display user expensive with filter and option to edit or delete entities. The in-second user interface UI visualize the user expensive using a better approach and clear communication graphically. The UI follow a modular design by separating data from the visualization component from the added expenses by the current user. Test plan. Core features such as sign up, login, ad wave, expensive and category filtering passed all test cases. The system responds correctly to invalid inputs and performed as expected during real-time updates and UI integrations. Theme switching and start wave also worked well even with known data. The problem faced included Firebase authentication handling, slight UI lag with large data sets and location permissions, confusion, manual input error feedback and seasons handling were improved to resolve this problem efficiently. Critical evaluation. The user of the facade pattern in the personal expenditure tracker simplifies the system through the unified interface, improving both capability and usability. Java was chosen over C++ for better Android SDK support, Firebase integration, and smoother UI and UX development with compatibility for dynamic usual and real-time cloud storage features. Conclusion. The personal expensive track app is a simple and helpful tool for managing daily spending. These are my references.